But if we're using groundwater for our drinking and agriculture and industrial needs, we also need to think about the environmental problems that are associated with groundwater use. We'll see that if we overuse, if we take out too much water from the ground, then rain can recharge through infiltration. It can completely threaten our groundwater supply. And especially here in Florida, it can cause sinkholes to develop, and it can cause the entire surface of the land to start to sink. But another important thing that we have to look at is contamination. With groundwater, it's constantly mixing as it's flowing. So if we get some kind of toxic, deadly contamination, we might have to completely stop using that water source and look elsewhere for safe drinking water. Here in the United States, a lot of our fruits and vegetables and our livestock are grown in a very specific region of the Midwest. And underneath this area, underneath like Wyoming, Montana, Colorado, Kansas, all the way down to Texas and New Mexico, is one huge aquifer. One giant rock that's capable of holding probably hundreds of millions of gallons of water. But because this area is agricultural, and our agriculture takes up the most amount of groundwater, we've seen that the aquifer within this area is very quickly drying up. So here we're treating groundwater as a renewable resource, thinking that the water is going to be able to recharge during a human lifetime. But because we've taken so much out of the ground, it's lowered the water table very substantially. And on top of that, climate change has led to many droughts in this area, meaning that it's not properly recharging. So we're seeing that this area of really intense irrigation to grow our crops is potentially facing the possibility of running out of groundwater a few decades into our future. But land subsidence is another major issue that happens when we withdraw too much groundwater too quickly. And land subsidence is just what happens when the land slowly starts sinking down. So if we start removing a lot of groundwater, the pore spaces that used to be holding water are now going to be filled with air. And that air is not going to be able to properly support the weight of the ground above it like water did. So those pores are going to start collapsing inwards, very slowly causing the ground above them to start sinking down. But in areas that have really thick amounts of loose sediment, this can lead to really substantial amounts of land subsidence. So in this image, we're looking at a man standing next to a pole. At the very top of this pole with a sign that says 1925, this was where the land was in 1925. Down at the bottom at 1977 is where the land is today. In 52 years of really significant groundwater withdrawal, here the ground itself sank 30 feet. That's very substantial, especially if you have things like roads, buildings, and bridges that are sinking 30 feet as well. But groundwater contamination is also going to be super important. And there are a lot of really common sources of contamination. Things like septic tanks if your house isn't on the sewage system. The sewage system itself is common to leak, especially in streams. And we get a lot of waste from farms as fertilizers and chemical residues. But depending on the type of aquifer, some aquifers are capable of naturally processing and trapping those contaminants, really similar to like a Brita water filter. And thankfully, limestone is great at purifying water, and Florida is almost entirely made up of limestone. So as the groundwater flows beneath our feet, it's actually purifying and trapping a lot of the contamination within that water. But once we have groundwater that is very heavily contaminated, we have to make the choice of whether we're going to abandon that water supply or spend a lot of money to treat it and try to remove some of those contaminants.